Welcome back, everybody. This is our video solution to problem 3 from Quiz 8, Fall 2023, Math 307, Linear Algebra at Cal State Fullerton. Let's see what we have today. We have an inner product space V and two elements V and W in that vector space. And we're going to set C equal to the ratio of the inner product of V with W with the inner product of W with itself. Okay, and we want to prove that the inner product of V minus CW with W is equal to 0, meaning that V minus CW and W are orthogonal. Okay, well, we're going to just do this directly, but the motivation for this, right, comes from the following, where you might have a vector W, right, so here we're working in the plane, and then maybe I have another vector V. Okay, so I have these two vectors, and I want to project V onto W. Of course, that means I want to come straight down, and there's no W. So what I could do is extend W out, so that I get a nice right triangle here. And so whatever this W is, right, it's some multiple. I mean, whatever W is, right, the length of this thing is going to be, in this case, longer. It could be shorter, but you have to multiply by some scalar. So you get some constant times W. And then, of course, now there's actually a vector going up. And that vector going up is V minus CW. All right. And by the way we did this in R2, we know that V minus CW and CW are orthogonal. Right? There's the right angle. But of course, if a vector is orthogonal to CW, then it also has to be just orthogonal to W. All right. Of course, none of this would make sense, right, if W is equal to 0 here. So we reasonably can assume that it does not. All right. So this is the motivation for believing that this is going to be true. But let's actually verify it just by expanding everything. So here, let's see. I'm going to take this and split it up as the inner product of V with W minus C times the inner product of W with W. And the way I do this, right, is using first argument linearity. I can break up over a sum and I can pull out scalars. All right, but now this C here, this C is exactly equal to the inner product of V with W over the inner product of W with W. And look at that. The inner product of the W's is going to cancel. And so I'm just left with the difference of the inner product of V with W and itself, which is equal to 0. And there we go, right? It's actually pretty easy, pretty slick. Okay, well, there we go. We will see you next time.